Hello there, welcome to part 3, and sorry for the hostility last video. Okay, now let's get it. Now, in this video, I'm going to avoid using words because, well, I'm just going to try not to use words. Alright, so, no restrictions. This means that negative infinity, positive infinity, like I said in the last one, where I had where I showed you that any function without a restriction gets you this. So yeah, we have a radicand, so that's what we need to solve for. And you said that. And remember, show your steps. Always show your steps. Do that, always. Fixing x equals 15. Yes, I know that is an odd fraction, but it's not negative. So that's good. Really good. So now we just put that to the domain. So we know that it has to be greater than or equal to. So we have our bracket because it can be equal to 15 to infinity. There we go. Alright. So now we have a fraction. Of course, you just set that not equal to 0. Remember that. Always have to remember that. So you add both on the sides. 8 to x, divide on both sides, and you have x cannot equal 4. And the domain, man, it's fine if you mess up because math is fun. You want to know why it's fun? Because even if you mess up, even if you do something wrong, you can always pick yourself back up. So all you need to do here is 2, 4. 4 to infinity. Sorry that kind of got mixed up, but yeah, that's our domain. So now we have another fraction. So 6x plus 96 and cannot equal 0. So subtract on both sides. And it's totally fine if we have a negative and a fraction together. It's totally fine. Okay. I know seeing a negative usually is a bad sign, but it's fine. It's fine. It's fine. Just deduct both sides. X can't equal negative 16. Can't equal. Alright? So, now, let's, go let's, do our domain. Sorry, I froze there for a bit. So, like, always, can't equal negative 16. So you have your u, negative 16. Okay, so you may be wondering what this u is. So whenever I write that, it's the equivalent to like an and. So like if you have a fraction, because that's my best answer right now. If you have a fraction and something is restricted or can't reach that, or it's not supposed to be in the domain, then you'd separate at where your number is or value is, and then you'd write that and finish off the rest of the domain. So it's basically just a separation to show you that a certain number doesn't really work with the function. So yeah, this just basically means and, but it's something else that you will learn in another day, because yeah, no. Now we have a radicand, so you set that yeet No, you wouldn't. I know you typically do that with the radicand, but you have to notice that is in a fraction. So that's bad. That's a mile right there. That's mile right there. So you actually make this not equal to 0. And then you'd add on both sides. And then get x cannot equal 5. Negative infinity 5. U 5 to infinity. So, you know, just remember that even if you have a certain restriction, if there's another restriction or above that restriction, just know that the restriction, I'm confusing myself. Let's just say this straight up. Gonna be concise. If you have a root under a fraction, the fraction is just, you're gonna have to set this equal to a fraction because it is the denominator of the fraction. The root is in the denominator of a fraction. Forget what I said in the first place. I marked this thing up. Okay, yeah, that's it. Pretty simple. So just remember, you have to remember the restrictions or else you will mess up. But math is fun. If you mess up, try again. Again, math is fun because math is fun. Math is fun and math is fun.